Hi everyone, we will start this live streaming video showing a little bit about Omdena project that I'm conducting and will kick off next Saturday. And it's about detecting and monitoring land use transformation in Córdoba, Argentina using satellite imagery. So the idea is that we compare satellite imageries from a same place in a time 1 and time 2 and try to detect change between those two images and eventually detect change as deforestation or stuff like that, illegal activity, basically. So this is the project of myself, basically because I was working similar projects for United States startups. So I have my Upwork profile where, let me have my link, where different companies and other freelancers hire me to make some geospatial technology and stuff like that. So yeah, I've been working in a similar project, and then I have this kind of this idea. Okay, first thing first, in Omdena they give you a Slack channel where you will host the event and all the people, and they ask you to have two things: a drive folder that I have kind of someplace here, and a GitHub repo. So I have a drive for myself and some information before sharing with all the people. And then the shared folder that I share with all the volunteers that will be working with us. Here, I always try to have one folder for data because, you cannot put the data in the GitHub repo. If not, it will get you an error. And more data like this one, it's like cost and really heavy. So you want to put it in places like Google Drive or eventually a bucket of S3 in Amazon Web Service. Then I have a curated Excel of resources and papers to read because the volunteers, maybe they are not really familiar with the topic. You always want for them to read about the topic and to understand from the problematic, from different approaches that other people did and stuff like that. So I was like, the last month I was reading like a lot of papers that I collect here, and I put like a level importance of read. So this kind of, it's from the problematic, understanding deforestation in the region and stuff like that. And then you jump to machine learning models and understanding different machine models that could apply to this. Deep learning model for change detection, giving two image, give me another image with the change. And then some new models that use LLMs to give the response an LLM. So there are some models. I believe it's this one. It's quite interesting for the change detection stuff because, yeah, what's the idea of this model? It's, hey, I give you a pre-change image, I give you the post-change image, and I want for you to give me the image with the binary change. This is not binary because it has like different colors, and also an explanation. Like, hey, what was the change? Many square buildings. So that's quite amazing. So yeah. And then after the GitHub repo that we will be working a little bit in the code in a midst. Here what I want to do before all the volunteers start working is kind of make a structure and define some stuff like the Python version. When I was in another project before, we didn't define the Python version, and all different people have different Python versions. And then when we start building all the stuff, we start getting issues. So this is kind of a basic one, and it could happen that you forget. So always try to do it. Then how to manage, create a VM, a virtual environment. That's also really important, and set up the Python version inside the virtual environment and stuff like that. And I was trying to leave it for Mac and also for Windows. I'm a Mac user, so for me, all the Windows stuff was built with ChatGPT because I don't know. And then, I will clean a little bit this because here I am asking like, hey, do several virtual environments, because essentially here, the front end, the models, and the back end, and the ready service, they will be microservice. So we will have those hosts separately. But for the development part and for people working, it's better to just have a VM here in the main folder. And then once we reach all our goals, we can put different VMs inside the folders. But essentially, you will have one in the model service that where different models of machine learning we have, and we could even have more than one virtual environment because some models, machine learning models, they are like really specific in the libraries they use, and you can have a kind of some errors. So yeah. Then for the pre-processing services, this will be kind of the backend. And here we will be working, because I'm working right now with Sentinel and some dynamic word analysis. The Redis, and I always like to make a sandbox. So we are a lot of volunteers, and if the volunteers start like doing different branch, that's not really the best approach, because you will start having a lot of branch and it's kind of a pain in the ass. So you want to give it a sandbox, and each volunteer, like for example me, creates a folder, and here I can safety test a lot of things before making a new branch, a pull request, and all that stuff. So yeah, that's important to do it. Okay, so let's go to the code, and I will show what I was creating before the kickoff. Before that, I have here a file where I kind of create a project summary with how we will do, how we will, the consideration, expected outcome. So each team already, when they start working, they know, hey, what you need to reach. All this stuff, it's like option. It's not like ready, and it will be changed based on the volunteer knowledge and their thoughts, because that's what you want from a volunteer. You want his expertise and his knowledge. So all this could be totally different after the project. One thing that I was working on, it was in the bottleneck and proactive solutions. So, when you make kind of a groups of people, if they are like if they separate between groups, and some group need some information from the other group. Give me a second, someone's hitting my door. Sorry about that. Okay, so I work a lot in the bottlenecks. So, for example, the teams of the machine learning models, they need the image to basically an image that it's already processed with deforestation in the time 2 and things like that. So you want to have that ready so they are not like waiting for the other the team to have those things. Or you want to say to the team, hey, be proactive. If you're waiting for something, just make something really quick for yourself so you are not waiting. And then when the other team is ready, you can improve it. For example, in that way, I was like searching for image to that they have like a change, and I found some image in in Kaggle, and they are not from the satellite imagery that we will use. They are actually for planets, so they are different pixel resolution, but that doesn't care. At least we have something to start using. Oh, they are TIFF files, so we will not be able to see it. Oh yeah, we are able to see TIFF file here. Okay, so I found this image. They are like 5-meter pixel resolution. They are really good. We will be working with images that are 10-meter pixel resolution. So, but yeah, at least you have something that could be used to. So take a look. Like this should be the one that is really that is older, and then you have like the same one with like a lot of. I don't know if this is deforestation or if this is just seasonal change, because that's a really topic. Like between months, the areas could look really different, and that's something to consider. But yeah, basically that. Okay, let's close this. Then if you want, I can share this file with you guys. I can share it here. So you have kind of something to read, and maybe it's useful for you for some kind of project or stuff like that. Yeah, let me take it out. Nice. Okay. Let's go here. Yeah. Let's start with the code. So I have this sandbox where I was doing different files to start analyzing. And we have this. Is this one actually? Yeah. So the first thing that we want to use is Google Earth Engine. Google Earth Engine, here you have it, Google Earth Engine. It's a really cool product of Google that it has free resources, and they are basically all you need for at least for an MVP. I deleted my cache, so I lost all my login sessions. But I already have a project, my friend. Well, we don't know. And they have like a lot of data sets like this, like here. So you have of weather, atmosphere, you have Landsat, that is from NASA, Sentinel, that is from the European Commission, MODIS, then you have high resolution, that is the NAIP, National Agriculture Imagery Program. It's a program that each like 4 or 5 years, like here, coverage, I don't know. Yeah, for 5 years, they take a full picture of the United States in a high resolution imagery, and it's for free, so that's amazing. But just for the US, so that's a little pain in the ass. Then you have land cover of all the entire world. This is amazing. You have like different colors from the different covers. So the red, it's supposed to be like buildings. So this could be like a city. Then you have the green could be forest. The blue could be water. So this helps you understand where the deforestation they are. Croplands and a lot of different data sets, and it's like really easy to use. Even that, if you like kind of open one, for example, we are using Sentinel. So if you click here, you want to use they have the SAR, that is a synthetic aperture radar. This is really cool. because they don't get interferes with the clouds, and the clouds for satellite imagery, they are always something to consider, and this type of measure, they don't have these issues. And we will using, I believe, the multispectral. Yeah, and we will using surface reflectance. Okay, so here you have like the multispectral, you have a description, you have the bands here with the pixel size. So you see here red, green, RGB image. They are 10 meters resolution. And then the thing that is you have here, it's already kind of a code to use this, and it's ready. And here you have it for Python. This is amazing too. Here they have like a code editor that is built based on JavaScript. So if you press here, opening code editor, it already opens to you, and you can run that code, and it will be and it will run automatically. So if you press here run, you will see. Give me one moment. Okay. Nice. Let's keep going with this. So yeah, so here I run the code, easy as that, and they have like a sentinel imagery of some places that look like, I don't know, India, Nepal, some stuff like that. Yeah, India. And you have the sentinel imagery of this place. And even if I go like I select here the inspector, I think it's called, and I place some, and I put it someplace like here, it will create a point. And if I go here inspector, I need to first hit there. No, so it was, I already forgot. There. So you press with the hand, you go to inspector here, you press, and they give you like that exact point. They give you different bands, his values. So you have RGB and the different ones, and then you have object, bands, and all the information in 1 second, and that's pretty cool. And maybe you can do like, I don't know if you can, and if I do a geometry like this, it doesn't look like it's changing here. Okay, but yeah, at least that's pretty cool. Then you can do more difficult things. Okay, so let's come here. I was already working with that, so I create kind of a file. It was the same thing that we did. We take from Google Earth Engine, we take the Copernicus, the Sentinel harmonized one. We do a filter to avoid clouds. So here we avoid the clouds, or a certain percentage of those. And yeah, and then we have another one that we will work in, that it's the land composition analysis. This use another dataset that is available there in Google Earth Engine, that is this one, the dynamic world. This is pretty cool because it's based on Sentinel. So each time Sentinel creates new image, this other dataset creates new image. Sentinel goes to the same place. They go once each 5 days. So like in 1 month, you can have like 6, 7 pictures of the same place. And that's amazing because other datasets, they don't have that amount of time that repeat. So they are really good in the, forgot the word, how you say it, the, someplace here, or here. The revisit interval. So revisit interval is 5 days. That's amazing. 5 days, it's like a lot. And here dynamic world v1, and it's based on Sentinel. So what they do this stuff. They categorize everything in water, trees, grass, flooded vegetation, crops, sugar and scrubs, build, bear, and snow and ice. And you can do the same thing as we did before, opening code editor. They will give you a pre-built code like this one. You run it. And they give you some place that they already defined. We can see it someplace here, they already define it. Looks like here they put the center. Here they put a geometry point, and this is like lat and log. I don't know exactly where this is, but we maybe can. Warsaw. So this is Poland. Yeah, Poland. Okay. So if we do some zoom in, you see here the layers. So if I take out the Sentinel, we just see exactly the different colors. So this is amazing because it could help you to focus where you want to work. For example, I don't want to work in cities, so I will avoid all the red colors with some logic code functions. I want just to work in places with forests. So we see here that there looks like a forest, and if we press, let's go a little up. Yeah, so that looks like some trees, you know. And if we put it there, yeah, exactly. Here you have like some farms, so they are mapped in a orange colors, and I believe this light green is like shrubs and grass, you know. But this dark green is like forest, actually trees. So that's nice to know. And yeah. Okay, let's go to the code. Here I import some stuff. I have a place where I save my credentials to Google Earth Engine, so they know that it's me. Let me open this. And if we run this code, let's see if it's still working or if it fails. Here, let me drink a mate. Okay, so we have some issue with the credentials. Get credential path. So I have in my .m file, where is, oh, I don't have my .m file. Oh, that's strange. So I do later. I was almost assured that I have a .m file, or I have it inside my sandbox. No, that's strange. .m. No, so maybe I deleted. Oh, maybe I was working in another file. I'm not sure. Data. Well, let's create this. So here for coding quickly, I will use my little friend of cursor, and we will just copy this code, paste it here, copy the issue, paste it here, and tell him, hey, help me with this issue. We will give him access to the .m file. So here he will have access to the .m file, and here are my credentials. So I will give him also access to my credentials. My credential of climate. Why it doesn't appear? Maybe because it's in the getting node. I'm not sure. Okay, here I have my credentials, and I will say I will copy and paste the relative path. And okay, let's see what he will try to do. Okay, he will try to make some change in the code in Jupyter Notebook, but for now they are not allowed to touch inside a Jupyter Notebook, just in .m file, that's this one. So as you see here, it fails. And he creates this stuff that looks great. Let's restart the kernel. Always in Jupyter Notebook, it's important to restart the kernel because sometimes it doesn't work the change that you do in another files. Okay, now it works, it passed. And now let's try to do this. So I define a variable that calls a function that is analyze site. It's a function that I did to understand to take image from the Sentinel and from the other data set that we see. And I did kind of some stuff like some custom stuff like, hey, you can do it in a period, so you can do it monthly, or you can do it quarterly, or you can do it biannual. Biannual means semestrally, or you can do yearly. Yeah, this is a really custom code that I was like fighting a lot this a couple of days ago. So if I just run this, and this take information from a CSV that I have here, and basically where they I can see where I have that information. Yeah, I know where I have. And so if we go again to the project, to the paper, how I get into that data set? Reading papers. So I was reading this paper here, monitoreo.desmonte.com.ar. I was reading this paper. I get in now with this page. They have a monitoreo de deforestación, and they have data and publish. It says here, and you can download. And if you come here, you can download different periods of time. And that's pretty awesome. And you can download also by states. That's also awesome. So you can here download Córdoba, for example. And okay. Yeah. And if that will download me a file here, Córdoba, and we actually, if I open QGIS, now, give me 1 second, we can see what's inside that file, and and take a look. And where is QG, guys? Oh, it's open. 1 second, please. Here we have QGIs. Later, I don't care. We start a new project. And let's see if it's available to, we just put this file here. No, it doesn't look like. Oh, I have here, yeah, other layers. Here you have. Okay, so here is adding all the layers, and we can, if we do right click, we go open attribute table, and we will see the columns that that has. So that has state, Córdoba, a city or department, and the acres that they were deforestation. But this data doesn't have a daytime, so that's an issue. And they have another data with daytime here. So, like for example, here you can see from this year to this year, and then you have the possibility to filter. So take a look. This is all Córdoba, all the deforestation that they map. It looks like really a lot, and we can actually put it and compare it with a map of the entire world. So if I put it here, we will see, okay, we see Córdoba with all the deforestation. Córdoba is all this part. And we see, hey, here is nothing of deforestation. No, there was a lot of deforestation there, and it's nothing to deforestate already. So it's sad. And all these parts are the places where we still have a little piece of forest. Córdoba is still to have like 3% of the original forest, so we don't have nothing. We destroy everything already. Here is the city, and yeah, we are destroying everything, and we are trying to not destroy more than we already destroy and recover with this project. Okay, let's keep it going. That being said, okay, I took data, I save it here in different ways. And here I pick one index from the data. So here you see site index 70. I pick what index from there, from here. So if you go to the index 70, it may be this, or maybe it's one less or one more, because maybe it doesn't take into account the title and stuff like that. And I want to understand yearly, starting from 2018 and year 2024. I want to understand that. And here we see all the images that we have available for each of these years in that place. So, for example, 2024, 130 images. That's a lot. If we divide it by month and by days, we will get like 130. No, the inverse, sorry. Each 2 days. It doesn't look right. Maybe I have something wrong, because this means we have a picture for even 3 days almost, but the data interval is 5 days, so something might be wrong or different. But okay. So I already called this function. Now, if we take the variable, we can see in a Python leaflet map, and we see here, this is the place that they match as deforestation, the red one. Here I have the different years. So if I take this, we see the place, is that place there. But what I see in this data set is that they map as deforestation a lot of places that they are not actually deforestation, because here we are seeing an image of 2024. we will now see of 2023. It's already the place there. 2022, the same stuff. 2021, a little greener, maybe some grass, but it's the same stuff. We don't see like they are cutting trees. 2021, 2020, 2019, and 2018, and they were always the same place. So we were trying to map the deforestation from 2023, but it's the same stuff. And if we saw it with the land cover data of 2018, we see it like this. We go 2019, the same place. 2020, same. 2021, same stuff. 2022, same stuff. 2023, 2024. So what that means that the work that these people do here, it's not perfect. They have a lot of issues, and that's okay because it's really challenged to make all this stuff. So maybe with our work, we can improve the work of these amazing people and even make it better. So let's try to do that. Okay. Take out this. So what I want to do. What I will want to do now is try to, from the series of places with data, but we know that several of them are wrong, essentially, because if I change to, I don't know, let's use 45, some site. I was like doing this manual inspection and I saw the same pattern. There is no deforestation in this place. It was already like this. So maybe they map a deforestation because they map it between one moment it was more green, more grass, or some stuff like that. Where is the place they map? Okay, so they have this place mapped. Okay, this is an image of 2024. This is an image of 2023, 2022, 2021, 2020, 2019. Okay, so it was always essentially similar. Let's keep this here. Okay. Yeah, I don't see any difference. So it wasn't the best model they use. Okay, let's try to improve that. How we want to improve that? We want to, from all the CSV, just have to just keep with the rows where the place that they map as deforestation, the year before, it was mapped in the dynamic world dataset as trees, as this color, the dark green, you know, because I'll take a look how this is interesting because we see 2024. Can you notice the loss of trees? It's not really clear. Oh, but take a look here. Sometimes it doesn't work so nice the map and you need to zoom in, zoom out. Take a look at this road here. And here they did that. Okay, so you have there a new place. So if we use this, where it was there. It looks similar. Okay, not so clear. So let's do that. What I will do, I will open this other place. Here I was like creating a code to from this type of files that they are .shap and they are with another files. These are essentially files to save geospatial data with his metadata. But from this, I want to save it in a CSV because if I try to open this, it's not so easy. If I open this file in QGIS, as we see before here, it will show me all these places, and essentially it will show me the same. But I want to have it in a CSV. So from here, what I do is I take those files and I convert it into CSV. So results to CSV, and then I do some more filters, like I filter between the years. So if I want just to give the ones between 2010 and 2023, so I do a for between years and I separate, you see, a CSV 2023, 2022, 2021, all that stuff. I print some stuff to see what's going on. And then here, oh, it's in Spanish, sorry about that. I'm not sure what I'm doing here. Oh, I just saved the CSV in a logic way. So I can run it again just to be sure it works because I changed some stuff in the code. Okay, and we have an issue already. Candidate board name, analyze site, analyze sites. Oh, this, I think I changed the name. Yeah. Now it's analyze site. Now model name config. I changed config to the .m file. So I will go here. We can do the same that is here. So essentially, I will copy this code, paste it here, and say, hey, I delete the config file, and now I save this info in the .m. Can you give me the code? So with that, he already knows the change that I did and will help me with the code. Why I'm using the chat here and not the composer? Because the composer is not able to modify Jupyter notebooks, and this is a Jupyter notebook, so that's why I will ask to this instead. So I will copy all this stuff, and then I come here, I paste all this like that. Let's see if it works. Not such file as data climate JSON. Okay, and why it works here? Oh, here it works because I did some stuff with the paths here. So let's do the same thing, I believe. Credentials path, whatever. Yeah. We run it again. Another issue. And we can first what I will do is separate this code in another block here, paste it, and delete from here so it's more clear. Let's restart the kernel just for and put a markdown here. I will put this markdown because you always run the code, it takes you to the next one and it's a pain in the ass. If I put that markdown there, if I run this code, it goes here and I don't get so much in there. Okay, so I will copy this code, paste it, copy the issue, paste it, and say, hey, here it's the JSON file in a relative path. And I come here, and here I have my copy relative path, paste it. If you have any question, you can ask me, and I will be happy to figure it out. Okay, so hey, I see the issue, blah, blah, blah. Let's fix it. Okay, my friend, let's fix it. Copy, paste. Okay, now it works nice. And I want to put all this stuff in the same piece of code, so it's like more easy. I am like really like to have all this structure in some way like this. And why you don't want this? I don't know. Let's keep it. You know, so like this. So I run it. Works nice. Okay, nice. Okay, so let's try to run again this cell. Now it runs okay. The second one, it will process again all the files and will overwrite the CSVs. Here it prints some stuff that I was doing to debug, understand. And if we run here, oh, this was the stuff that I was trying to work and it was failing. So I was trying to, let's process. Process deforestation CSV. So it's getting like a lot of errors, saying that we don't have image, but that should be wrong. So what I will do is basically use Composer. So let's clean this. Let's clean here. Let's stop this. And I will say to Composer, I will give access to Analyze Site. Yeah, I will give access to Sentinel and to Land Composition. And to the CSV, so 2023. So I will say, hey, I have this data of deforestation, and I call again the 2023 CSV. Yeah, here we can collapse. I want to filter this with the, and we call the this data set. So I want to filter this with the data set took, and we come here, and I want to give more information about this data set. So I will copy here about the stuff. So I paste this stuff. I want to filter the CSV to just keep the logs where they are in here, in a place that is the estimated probability it's of trees, where they are in of trees, okay? But we want to do it to map it from data that was trees 1 year before, but because if we have a data set of deforestation, it's much probable that we will not have any place with trees, because deforestation means no trees, basically. But I want to do it using the data of the data set. And let's copy again the name of the data set here. From 1 year before, because it's deforestation mapping. I want to use the data of 1 year before to assure it was trees. And now it's deforestation. It's that clear. And you make a new code here, and maybe we create a new Python file, call it a filter deforestation .py. Then maybe we make it better the name, and we filter deforestation, and we also add it here, filter deforestation. Yeah, let's. Can you make a new code? Filter. Yeah, there it is. Okay, and we will use the agent here. So let's see what it comes out. So it says, hey, we help you create the script. Let me create it. Here it's creating some stuff, so it's like ongoing. Give me 1 second and we will review that code entirely. Yeah. Okay, let's go. So he created a lot of code. Take a look. A lot of code. And here he will essentially tell me, hey, this script includes initialization, get recovers, filter deforestation data, run the script directly, read from this file, Córdoba. Oh, if I press, oh, okay, it opens. Nice. It will write another CSV with the filter data, and it will add a new column, prep year 3 coverage. Okay, so essentially this is the thing that I was asking to. But let's accept the file and let's try to run it. And we can ask it. Actually, we can ask to the agent here to run it itself. So we will not do anything. We should ask, okay, please activate the VM, the virtual environment, and run the code, please. Let's see if he do it right. So he says source VM being activated, and that's perfect because I have the VM, call it VM, so run code. And I need to approve this, but you can like, where it is here, cursor settings. Someplace, yeah, it tells you like, hey, I will do it without asking you permission. Here, enable YOLO mode. Allow agent composers to run tools without asking for confirmation, such as executing commands. So if I click on this one, I can add a command of allow list. So I will allow to run a Python file. I will allow to activate the VM, but I will not allow to delete things from a database. Some stuff like that. For now, I will leave it like unchecked, but it's a pretty nice tool. Okay, so let's run it here and let's see what happens. Here, essentially, it's running in the terminal. And what is nice, it's this. If it gets an error, he already gets it. So I don't need to copy from the terminal the error, paste it, and say, hey, fix this. Here it gets an error. He says, hey, I see this error. I will fix it. And he goes to the file and fix the file. That's amazing because we don't need to do anything there. So here, okay, it's fixing a lot of stuff that I'm not sure, some paths, I believe. So let's set file. And he's asking me, hey, let me run it again to check that this is working properly. So we run it again. Okay, it looks like he reads some records. He's still going. He read 99 records, I believe, from here. From here, how much we have? Yeah, exactly 99 because it's not considered considering the titles. So 99 records. That's right. He's saying me he processed 10 records. Okay, like he's comparing these rows with this data set. So he's comparing where of this data set and he's reading and letting me know, hey, I already did 10. Okay, we have any? No, sorry. It was the issue before. So it goes 10 by 10 by 10. It takes some time because it's a lot of satellite data to compare, but yeah. Okay, let's keep going with that. Let's see if after all this it doesn't get an error because sometimes that happens. Like you do all the heavy stuff, and then you get an error, and then you remember, hey, first it should be nice to just filter a little part. Okay, so but this time it didn't get an error, so that's nice. Great, the script ran successfully. Here's what happened. I read 99 records. That's correct. I processed all the records, checking their tree coverage from 2022. I just found 14 records that had significant tree coverage in 2022. So I filtered out 85 records and I saved the results. Okay, that's nice. And he's trying like to read the results. No need, my friend. I will do it just here. So I will cancel, and for now we leave it there. Okay, so we have these places, and so now let's try to use this data set instead of the other one that it wasn't with filtered. So I believe I need to change the CSV someplace here. Let's see here, yeah. So here it's using data, Córdoba per year. It's in Spanish, sorry about that. And we will use this one instead, Córdoba 2023 filter. Yeah, and maybe, and we can, yeah. Okay, let's try to do that. I will close this, let's close this. Keep it simple. Restart, run. And because we have 18, if I have the 45, because we just have here, oh, we have less, we have 14 places. Okay, so if I put 45 here, it will give me an error. Hey, we don't have so much, we have just 14. So, no, sorry. If I go 1, there it should work. Let's see. Okay. Okay, so he tell me he find photography image. So if we go map, let's see the place where it is. Okay, we see a straight line here, and we can have it like that. Okay, so that line. This is the image of 2024. So if I uncheck this, we see 2023. If I check this, okay, that's great. Because take a look what we see. We have trees in 2022, but then 2023, they take it out. Here we have a mapping of deforestation looking great. Well, I get excited about deforestation, that's sad. Sorry about that. And even if we go back in the time, we can maybe map other places of deforestation. But it doesn't look like. So if I compare 2018 with 2024 directly, do you see another place? Here, take a look. Here you have like some trees, and 2024, you lost it. It's tricky to see this because you don't know if it's like a seasonal change or if they are actually trees, but here it's pretty clear. And if we use the land cover, we can compare it also. So take a look. Before it was here, the dark green was bigger, and this is the 2018. And now if I check the 2024, it's really different. And let's see if we see another place. Sorry that I go like, yeah, here where I tell you before, this place, we see some yellow or some green, and in 2024, everything out. So if we see the image, oh no, oh yeah, sorry. So 2024 is like that. 2018, it has some trees. So, okay, our filter works perfectly. So let's try and let's see the second just for fun. It's sad to get excited about this kind of stuff, you know, but okay. Actually, I have family that they have lands. They are farmers. So they do a lot of deforestation. And for them, it's like money, and it's his way of getting money and pay his things. So it's a little sad. So, and here I create like to see how much acres we have. In the one before it was 50, so it was like a lot. This one, they are 7. Not so much, but they still work. Okay, so we have that side pretty clear. It's like different from the rest. It could be like a mine or something that they take land because it's like really different. So we will see in here 2024, 2020, 2024, yeah. Here 2023, and here 2022. It was full cover of trees, and then the next year, deforestation. So yeah, we did a great job here. I think that with this we will end the streaming because it's already kind of late and we already fixed what we want. So, and we can do the same that we did before. We uncheck everything and we compare 2018 with 2024. Do you see? Okay, take a look. All this place full of trees, 2024, out of trees. So, and here too, here you see a lot of trees and then out. You don't know what is. Maybe it's deforestation, maybe it was a fire. It's not sure. And we can do it using this map. Oh, take a look. All this place, it was full of trees. And in 2024, it's all full of grass. So let's see it there. And the road is bigger. You see the road? It's bigger. Yeah. I don't know which city is this. If we uncheck La Higuera and Rio Salcate, how far away from me is it? It is. Okay. So I live here in Córdoba, La Higuera here. Yeah. And then if we, let's try to find one that is with like a lot of deforestation. We can see here. So if I go and see here, so we have the first one, 14, here, this one, 112. And here we have 127. Okay, let's try to get this one, San Carlos Minas. This is 9 or 8, I don't know. Let's see. So if we do 9, now that it wasn't that, let's try 10. And we need to interrupt. And now it wasn't that neither. Let's do 8. Oh, it wasn't that neither. Where it is, my friend? 7. Here, okay. 127 hectares. I don't know how you say it in English. Let's ask. Oh, hectares. Okay, and acres in Spanish. Oh, it's okay. Yeah, acres. Okay, so this place, it was like a big deforestation. Let's try to see what's happening here. Take a look. All the places that they deforest. All this big triangle, and we can see it's not just this. This was maybe 2023, but maybe all this also was part of everything. So this image is 2024. This image is 2023, and we already can see some 2024 deforestation. Take a look. All this is 2024 deforestation. Okay, take a look. So clear. 2023, uncheck. You see all that stuff there. Let's uncheck 2022. Still, take a look. It was a big forest there, and in a couple of years, they disappeared. 2021, 2020, and we can compare directly 2018 with 2024. So we see a lot of change here, here, here. Yeah, actually we see like more trees in 2024 here that looks like a city or some stuff like that. And if we compare the land cover maps, you see that it was like a full of trees. And then we put the land here and I didn't see these buildings. And we have a building there, looks like. Let's take a look. Where they see a building in the 2024 picture there? Oh, it's strange. And here, maybe it's my eye is not so good, or maybe the map is wrong because sometimes these maps are a little wrong, but that happen. And where is this? El Chacho. Okay, it's like really in the middle. Okay, that being said, we filter a CSV with deforestation data successfully. So with this, we will end up the streaming of today. I hope you learned something. I hope you like it. So yeah, that's all for today. Bye bye.